In this video, we are going to be taking a look at the concept of hydrolysis. Hydrolysis occurs when a salt dissolves in water and its anion and cation reacts with water to form either a hydronium ion or a hydroxide ion. Now, the first question we need to ask whenever we are studying hydrolysis is, where does the salt come from? So, given that we are studying acids and bases, a salt comes from an acid reacting with a base and becoming neutralized to form our salt and water. It is important for us to be able to work backwards and, upon analysis of the salt, determine what base and what acid the salt came from. And this will be later on when we analyze the behavior of the salt. The second term that we need to take a look at is that of the anion. When we take a look at the anion, the definition of an anion is a negative ion. When we look at cation, the definition of a cation is a positive ion. And anions will react with the solution to form a hydroxide ion, and cations will react with the solution to form a hydronium ion. When you read the next statement, it says, explains why the equivalence points in acid-base titrations are not always 7. So when we analyze the reaction of acids and bases, at the point of neutralization, there are no longer any acids or bases left over, but a salt is present. And depending on where the salt comes from, either a strong acid or weak acid or a strong base or a weak base, will then affect the subsequent reaction of the salt and its respective ions with the water. Now, there are two types of hydrolysis. The first hydrolysis is the anionic hydrolysis. It is the reaction of the negative ion with water to form the hydroxide ion. Now, in your list, in your data table of the acids and its conjugate base, pretty much every single weak acid is going to form a negative ion or an anion that will react with water. There are only 5 which do not, and they come from the strong acids. So if you take a look at this list over here, you have ClO4, which comes from HClO4, which is a strong acid. You have Cl-, which comes from HCl, which is a strong acid. You have I, which is also comes from Hi, which is considered a strong acid. Br, which comes from HBr, which is a strong acid. And finally, you have NO3, which comes from HNO3, that is also a strong acid. So in this case, when you take a look at your acid and conjugate base chart, the first 5 acids, which are considered to be strong acids, its negative ions will not react with water. The second type of hydrolysis is the cationic hydrolysis, and that is the reaction of a positive ion with water to form an acidic solution. Now, this is something that you need to remember. It is that metals from group 1 and 2 will not hydrolyze with water. The only exception is that of beryllium. Now, unfortunately, you will need to memorize this. Now, there are some other ions that will react with water, and they are aluminum, iron, chromium, and ammonium. And it will be very helpful for you to take a look at your data chart and see where these positive ions are so that you become familiar with them. We will not go into talking about the reaction of these positive ions with water at present, but we will do so later on. But one encouragement I give you is to take a look at these positive and negative ions as listed in your chart and become familiarized with them so that we will be able to complete calculations in the subsequent section. Now there's one thing that we need to make a note of as we analyze these hydrolysis reactions, is that they look very similar to the weak acids reacting with water or our weak bases reacting with water. But there's one important distinction. If we take a look here at F- reacting with water to form HF plus OH-, and now we look at a corresponding reaction whereby we have a weak base, in this case NH3, reacting with water, you will see that both of them generate a hydroxide ion, and they both react with water. So the question you might be asking, well, what is the difference? The difference is in what is creating that hydroxide ion. In this first case, you see that we have an F-. This is an ion. This then is a hydrolysis reaction. Note over here that we have an NH3. NH3 is not an ion, it is a weak base. In this case, although it forms a hydroxide ion, but because it starts as a weak base, this is not hydrolysis. So the important distinction is the hydrolysis is the reaction of an ion with water, whereas a typical weak base reacting with water is not called hydrolysis. Similarly, if I take a look at a weak acid reacting with water, so for example, if I now take HF and I react it with water, I form F- plus hydronium ion. Similarly, I can have NH4 reacting with water, and again this will also form a hydronium ion. So in both cases hydronium ion is formed and they both react with water, but when we analyze this, the NH4 is an ion, and so as a result this would be our hydrolysis equation. But when we take a look at HF reacting with water, the HF over here is a weak acid. And as such, because HF is a weak acid and not an ion, this then would not be considered a hydrolysis. So hopefully this little bit at the end helps you to distinguish between a hydrolysis reaction and a non-hydrolysis reaction.